Hello and welcome to Computer Science 40S. This is Greenfoot, Chapter 4, and I'll be dealing with this a couple different ways there. The first part of the chapter, I'll do several sections together, and then I'll take a break and make a second video after that. Okay, so we're on page 52, finishing the crab game. You should also have this worksheet that I've created for you to sort of follow along and jot down your thoughts. So you can see I've already got answers on here, but you won't have the answers just yet. Go to the crab world so you don't see the answers. So in this chapter, we'll finish the crab game. Finish here means that it's where we stop discussing the project in the book. Of course, the game is never finished. You can always think of more improvements. We suggest some ideas at the end of this chapter. First, however, we will discuss a number of improvements in detail. Number one is adding objects automatically, and you've probably gotten quite tired of doing this. We're now getting close to having a playable little game. However, a few more things need to be done. The first problem that should be addressed is the fact that we always have to place the actors manually into the world. It would be better if it happened automatically. There's one thing that happens automatically. Every time we successfully compile, the world itself is created. The world object, as we see it on screen, the sand-colored square area, is an instance of the crab world class. World instances are treated in a special way in Greenfoot. While we have to create instances of our actors ourselves, the Greenfoot system always automatically creates one instance of our world class and displays that instance on the screen. So that's sort of a special thing about the worlds, is they're automatically created. Let's have a look at crab world source code. If you don't have it, it's little crab 4 in the blank ones, and I've got that up available here. I've called it little crab 4.3 or 43. I've been working with it here just trying to get ready for this video. So, and again, you should always save a new copy, a working copy, so that you can go back to your blank one if you need to. Okay, so if we open up Crab World, you'll see exactly what's in the book. Basically, it's nothing. In this class, we see the usual import statement of the first line right here, import Greenfoot. We're going to discuss this later in the book, but it's always going to appear at the top of our Greenfoot classes. Then follows the class header and a comment. We've talked about comments already. The book doesn't talk a lot about it, but I have. So you can see these comments here and the symbols that are used to create them. Next comes the interesting part. This is called the constructor of the class right here. Constructor looks quite similar to method, but there are some differences. First of all, a constructor has no return type specified between the keyword public and the name. So there's no void or int or anything like that. And the name of a constructor is always the same name as the class. So in this case here, the class is called Crab World. Constructor is a special kind of method that is automatically executed whenever an instance of this class is created. It can then do what it wants to do to set up this new instance into a starting state. In our case, the constructor sets the world the size we want to 560 by 560 cells and the resolution of 1 pixel per cell. We will discuss full resolution in more detail later in the book. Since this constructor is executed every time a world is created, we can use it to automatically create our actors. If we insert code into the constructor to create an actor, that code will be executed as well. So here's an example. Public crab world. You can read it there. I would suggest that you not type that in right away. They're going to go sort of through the different parts right away. So you can just look at it and try to figure it out. And they're going to explain, I'm going to explain it to you over the next few minutes here. So this code will automatically create a new crab and place it at a location of 250 and 200 into the world. The location is 250, 200 is 250 cells on the left edge and 200 cells on the top. The origin, 0.00, is in the upper left-hand corner. That's 00 right there. So 250 would be over 250 and down 200, somewhere in around this area right here. We're using 4 new things here: a variable and assignment, the new statement to create the new crab, and the add object method. Let's discuss these elements one by one. So section 4.2, creating new objects. If we want to add a crab into the world, the first thing we need is a crab. So I'm going to go back to my source code here. Crab in our case is an object of the crab class. Previously, we created crab objects interactively by right-clicking the crab class and selecting new crab from the pop-up menu. Now we want our constructor code to create the new crab object for us automatically. The Java keyword new allows us to create new objects of any of the existing classes. For example, the expression new crab creates a new instance of the class crab. The expression to create new objects always starts with the keyword new, followed by the name of the class we wish to create and a parameter list, which is empty in our example. The parameter list allows us to pass parameters to the new object's constructor. Since we did not specify a constructor for our crab class, the default parameter list is empty. You might have noticed that the instruction that we select from the class's pop-up menu to create objects is exactly this statement. In our constructor code above, you'll find the new crab construction as the right half of the first line that we inserted. I'm just going to type it in here now. It's going to be new crab. Okay, so this creates that crab. It's the right half of the first line that we inserted. When we create a new object, we have to do something with it. In this case, we have to assign it to a variable. So it doesn't, it sort of just like loads it. It's not actually in memory anywhere. So in 4.3 variables, in programming, we often need to store information to remember and to use it later. This is done by using variables. And of course, we use those in grade 10 and 11 pretty much right from day one. It's pretty much one of the fundamental building blocks of any kind of programming. A variable is a bit of storage space. It always has a name to refer to it. You guys know all this. When we draw diagrams of our objects or code fragments, we usually draw variables as white boxes with their name to the left side. So there's a picture there. Now, we haven't discussed this a whole lot in previous classes, but variables can also have a type. The type of a variable states what kind of data can be stored in it. For example, the variable of type int can store whole numbers, integers. A variable of type boolean can store true and false, and a variable of type crab can store crab objects. In our source code, when we need a variable, we can create one by writing a variable declaration. A variable declaration is very simple. We just write the name and the type of the variable we want, followed by a semicolon. For example, if we want an age variable, as shown in figure 4.2, to store whole numbers, we just write int age. This creates our age variable ready to store int value. So you have to actually declare it at the start of the program. This is not something that you had to do in Scratch or Liberty. Liberty, you just simply had to start using the variable. In Scratch, you actually had to create the variable by going through the menu process of creating the variable. Once it was there, you could just use it. So you were in effect declaring the variable in that sense. But Greenfoot Java is a little bit more harsh when it comes to this. So you actually have to declare every variable that you want to use. And the scope of those variables, where they can be used, is a whole lot more important here as well. Okay, so int age. Once we have a variable, this is section 4.4. Once we have a variable, we're ready to store something in it. This is done using an assignment statement. An assignment is a Java instruction written as an equal sign. For example, to store the number 12 into our age variable, we can write age equals 12. It's best to read assignment statements from right to left. In other words, the variable value 12 is stored into the variable age. After this assignment statement is executed, our variable will hold the value 12. In our diagrams, we show this by writing the value into the white box. Flip the page. The general form of an assignment statement is variable equals expression. That is, on the left-hand side is always the name of a variable. On the right-hand side is an expression that is a value, and its value is stored into the variable. Often in our programs, we want to declare a value and store a value in it. So often we will find the declaration, variable declaration, and assignment statements go together. So for example, int age, and then age equals 12. Because this is so common, Java will actually allow you to write these two statements together in one line. So int age declares it, and then equals to 12, that actually assigns it. Assignments overwrite any value previously stored in it. Thus, if we have our age variable now storing the value 12, and then we write age equals 42, the new value is 42, and 12 disappears. It's overwritten. Okay, so those are sort of standard primitive variables. We mentioned above the variables can not only store numbers, but they can also store objects, and that's the key idea here in Greenfoot. It's not something that we used in Liberty Basic. It wasn't available. Scratch sort of does this. Java distinguishes primitive types and object types. Primitive types are a limited set of often used data types such as integer, boolean, and character. There are not many of them, and Appendix D in the back of the book shows all the different primitive types. Now, every class in Java also defines a type, and these are called object types. So with our class crab, for example, we get a type crab. Our lobster class defines a type lobster, and so on. We can declare variables of these types. So crab, my crab, means set up a new variable of type crab. In other words, it stores crabs, and going to call it my crab. Note that again, as before, we write the type at the front, followed by the name, which we can make up, my crab, and a semicolon. You could use many different names for the variable here. You could replace my crab with crab1, crab2, Bob, whatever, any name you want. Page 57. Once we have an object variable, we can store objects into it. We can now put this together with our instruction to create a crab object, which we saw in section 4.2. So crab my crab sets up a variable of type crab called my crab, and then my crab is equal to, and then you create a new crab. As before, you can write that all in a combined single line. And this single line of code does three things. It creates a variable called my crab that's of type crab, creates a crab object of type crab, and it assigns the crab object to the my crab variable. When we have an assignment statement, the right-hand side of the assignment is always executed first, and then the assignment to the variable on the left takes place. In our diagrams, we store object variables storing objects using an arrow. Here, the variable my crab stores a reference to the crab object. The fact that the object variable always stores references to the objects and not the objects directly will become important later. So we will always be careful to accurately draw like this. It's very kind of difficult to explain at this point, but it doesn't actually store a value, it stores a reference. It stores sort of like a roadmap to that object. The type of the variable and the type of the value assigned to it must always match. You can assign an int value to an int variable, and you can assign a crab object to a crab variable, but you cannot assign a crab object to an int variable or any other non-matching combination. In Liberty Basic, this was known as a type mismatch, and it happened when you were trying to store strings into numerical arrays or numerical values. Basically, what happened was you forgot the $sign, and you got a type mismatch. Okay, so you should try exercise 4.1 or 4.2 and write your answers down on the sheet. I've provided the answers for you elsewhere if you're having some difficulty. And then on the next page, exercise 4.3 all the way to 4.6 should be completed as well on the worksheet. Okay, so now 4.6, using variables. Once we've declared a variable and assigned a value, we can just use it. We can just use it by just using the name of the variable. For example, the following code declares and assigns two integer variables. Int n1 is 7, int n2 is 13. We can then use them on the right-hand side of another assignment and call it sum n1 plus n2. After the statement sum contains the sum of n1 and n2, if you write n3 equals n1, then the value of n1, the 7 in this case, will be copied into n3, assuming a variable n3 has been declared previously, and n1 and n3 now both contain the value 7, and they're giving you a little bit of a hint here, some foreshadowing. So you should complete exercises 4.7 to 4.9. 4.9 will be a bit of a challenge. The hint that I was just talking about should help you with that. And again, I've provided answers if you're really stuck. I suggest you pause the video here. Okay, so now section 4.7, adding objects to the world. We've now seen how we can create a new crab and store it in a variable. The last thing to do is to add this new crab into our world. In the code fragment in the constructor code shown in 4.1, we've seen that we can use the following line. Add object, myCrab 250-200. The add object method is a method of the world class, and it allows us to add an actor object to the world. We can look it up by looking at the class documentation for class world. There we see that it has the following signature. So this, again, this is a method that's in the world class, and so it's inherited. Reading the signature from start to finish, this tells us the following. The method does not return a result. Void returns type. Void is the return type. It does not return a result. The name of the method is called add object, and it has three parameters, and they are named object x and y. An object is a type actor, and the type of the other two is an integer variables. This method can be used to create a new actor into the world. Since the method belongs to the world class, and crab world is a world which inherits from the world class, this method is available in our crab world class, and we can just call it. You don't have to use the dot notation, the Greenfoot dot. We've just created a new crab and stored it in our myCrab variable. Now we can use this crab by using the variable it's stored in as the first parameter to the add object method call. The remaining two parameters specify the x and y coordinate of the position where we wish to add the object. All the constructs together look like this. We can use an object of type crab for the actor parameter because a crab is an actor. Class crab is a subclass of class actor. So in exercise 4.10, you are to add code to the crab world constructor of your own project to create a crab automatically as discussed above. So they showed you how to do it. This is what it's actually going to look like. Okay, so let's just go. We're going to declare. Let's put this on a new line. Crab is the variable type. myCrab is the variable name, and we're going to assign that to a new crab, like so, semicolon. Okay, so that just sort of creates it. It doesn't put it on the screen just yet. Just sort of creates it. It now exists. It's kind of like loading an image in Liberty Basic. And then to actually put it on, you're going to call the method add object. And we're going to add what object? The variable myCrab. Spelling's important. And we're going to put it at location 250 and 200, like so. Okay, and if you close that, and apparently I've got some sort of error here. Let's see what happens here. Hopefully that worked for you. There we go. Okay, so now, and if you want to see how it actually works here, what you do is just move your guy around, hit reset. He should always go back to there, okay, because it's automatically created. So that's exercise 410. Exercise 411, you are to add code to automatically create 3 lobsters in the crab world. And in exercise 412, add code to create 2 worms at arbitrary locations. So you're going to have to, in crab world, you're going to have to use this as a guide and create 3 lobsters and 2 worms. Now, what I've asked you to do, the book doesn't ask it. What I've asked you to do is use at least 1 random number generator. You're going to have to think about that. It's going to be a bit of a challenge to complete those. I will point out that each of the new objects is going to have a new variable name. So in other words, you can't just call each one my lobster. I'll leave it at that. Let you figure that out. If you're really stuck, you can look at the answers. So I suggest you pause the video here. Okay, now we're on 4.8, save the world. You're finally going to learn how to save the world today. All right, so it says, first remove the code again that you introduced in the last set of exercises. I didn't actually type it all again, so I'm just going to easily remove it. And when I close it, it's gone. Okay, so that's exercise 4.13. And then it says, place the following actors into world interactively, 1 crab, 3 lobsters, and 10 worms. So we're going to take 1 crab, 3 lobsters, and 10 worms. Like so. Okay, here's the fancy part. Right click, save the world. And then look at that. All of that stuff has now just been written for you. Okay, the book says, when you place some objects into your world and then select save the world function, you will notice that your crab world source code opens and some new code has been inserted into this class. Study this code carefully. So let's have a quick look at this here. You'll see that the code now does the following. The constructor now includes a call to a new method named prepare. So instead of all of this being in the crab world method, we've created a new method called prepare, like a subroutine, and then it drops down to here, and this is where it does all that. You will notice that each one of these has a new name. Okay, so for example, we've got lobster, lobster 2, lobster 3, worm, worm 2, worm 3, and so on. I would probably, if I was doing this, probably do a little bit of spacing. So there's the crab stuff, there's all the lobster stuff, and there's all the worm stuff, and so on. I would probably do that. Okay, so hopefully you figured out how to do that, and you can go in now and edit. You can change some random number stuff if you want. This, of course, is very, very similar to the freeform program that we use in Liberty Basic. Okay, so just finishing up here, page 61. When we create objects interactively and then select Save the World, Greenfoot writes code into our world class to recreate the situation just as we set it up by hand. It does this by creating and calling a method called prepare. The effect is that now every time we click compile or reset, the actors are effectively immediately created again. Our previous exercises to work the code manually to create and place the actors help us understand how this method works. In many cases, we do not need to write this code manually, just like freeform, and can use save the world instead. But it's important to understand it in detail. There are other occasions where we want a more sophisticated setup where we will still write the initialization code by hand. So in other words, they made you go through all that just so that you can understand what's going on here, okay? Sort of building some building blocks for the future of your future program. Okay, I'm going to pause there. This is almost 20 minutes long, and we're going to start with animating images on the next video.